Greetings, Mathies. Sorry I'm not here. This is a practice problem criterion D. So you probably have one of these in front of you. If you don't, you can download it or just walk along with me. And I wanted to show you kind of what sort of things to look at with this. So this would be similar to what you'll see on a real criterion D. So vertical cliff, person looks out of over the ocean, sees a whale at the surface, and wants to figure out how far that whale is from the base of the cliff. They have an inclinometer, which tells you angle. So sometimes you see them like this with a little dangling piece like that, and there's marks to tell you what the angle is, and with a little plumb line, something like that. Measures to the nearest degree. They know some of the information. There's the information. Okay. Now, first of all, all that information is not necessarily useful. So let's make a little sketch. Okay, so here's the cliff. Here's the ocean. And here's the whale. Right. Maybe for simplicity, let's ignore that and just go dot. And here's the dude, dot. Or person, the mathematician, who knows. And so they're looking down at the whale, something like that. Maybe you'd want to put something like this in here. That's the horizontal. This, we call this angle the angle of depression. We've talked about that before, theta. All right. So the depth of the ocean, no one cares. The height of the cliff, 80 meters tall. Yeah, probably important. That's this side, 80 meters. Ching. The height of the person is 1.7 meters tall. That's important because, if this is 80 meters and this is 1.7 to that person's eyeballs, this is an appreciable portion of that. So maybe you want to put that in there too. Angle of depression is 6 degrees. Oh, not 60 degrees, just 6 degrees. Now, this is an important piece because 6 degrees isn't this. It's the angle of depression from horizontal, so it's that piece. All right, so there's my labeled diagram. Maybe this is horizontal, and this is line of sight. This is the whale, and there's the person. Cool, great. Identify relevant variables. Well, we might want to say let h be the height of the cliff. Maybe t be how tall the person is. Maybe d be the distance the whale is from the cliff base horizontally. What else? Don't care about the mass. Maybe that's interesting. I'm not sure. We'll get there. 14 to 16 meters, because it could be that are we looking at the middle of that whale or the tail of the whale or the head of the whale? Maybe that could come in. So I'm not sure. I might just put that in there. 15 to 16 meters. Maybe that's important. Calculate the distance between the bottom of the cliff and the whale. Okay. So then I would take this fancy triangle and simplify my diagram. Right? I drew a picture. Now let's draw a diagram. That's 80. That's this is not 6. This should be 90. So this is 6. This should be 84. So I think this is 84 degrees. And we want to find D. So my distance would be I'd probably use, this is the angle, so we have opposite and adjacent, so we'd probably use tangent of 84 equals opposite over adjacent. Crunch it in my calculator. So tangent of 84 I found is 9.5143 blah 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 blah. As you multiply those as you work through this calculation, keep all the decimals you can. Instead of writing it out, I'm just going to say times 80 to multiply both sides by 80. Boom, boom, and I got D is 761.1491563. I'm assuming it's in meters. Now, might leave that for now. Calculate the distance. There's the distance. I might leave that, just leave all of it for a second. And then we'll start to think of like, do we keep this and this and this and this, or do we like round it? What do you want to round to, etc. So the next one you can guess is going to be like, explain your degree of accuracy. So maybe I might go back and say, okay, let's round this to 761 point, well, if we leave it as, if we round it to, if we just leave it like that, a meter is pretty big. And so, you know, I know that we're talking about 80 meters, but if we just leave it as, if we lose this, that's 14 centimeters. Maybe, I guess we're talking about meters and we're talking about the distance to the whale, degree of accuracy. I might be able to round to like 15 centimeters. That's as big as your hand. Is this really 80 meters exactly? Or could it be like 80 and the size of your hand extra? Maybe, because maybe there's like a little bump up here on the, you know, where you're standing. So is it worthwhile leaving that? Does that really make your, calculation seem, I know that it seems like more decimals are better, but this is meaningless. Like writing this and leaving this makes you look like you don't really interpret numbers well. So probably I might remove that and just say that our distance is 761 meters. Maybe you'd say 0.2. 20 centimeters is a little bit bigger than your hand. I don't know, maybe the size of your forearm. If you're talking about the distance to a whale and 80 meters of building, like our building is only 8 meters tall. Think about 10 of our buildings stacked on top of each other. Does 20 centimeters make sense to add in there? I submit no. I would just call it 761 meters. And I think that is, because how accurate do you think this is? Not, right? How accurate do you think this 6 degrees is on here? Probably, I don't know, probably not. So I think I would say something like I rounded to 1 meter of accuracy, or 1 meter. Maybe you'd round to the nearest half meter, maybe. So if this was like 3.5, maybe I'd round to 0.5. Maybe that would be significant, but I think I might just leave that. Rounded to 1 meter. Maybe since our certainty in height and angle is limited. Yeah, and the height h, sorry, I'm just kind of writing quickly, is so large compared to the 0.15. Maybe we can leave that out because it doesn't seem significant. Compared to 760 meters. If you run 761 meters, do you think you care about 0.15 after? No. So compared to 761, something like that. Okay, explain how this solution makes sense in real life, in the context. Well, if this was, I'm gonna put that triangle back. Oh, that's not the triangle. This is not the triangle you're looking for. If we take that same triangle, and look at it here, a 6-degree angle, if this is 80 meters, a 6-degree angle of depression might look like that. It's like way over there, right? It's 6 degrees is pretty small. So I think it might look more like this, just roughly. If that's our 80 meters, that's horizontal. 6 degrees is pretty small, it's like that. So going way over here to get to this level would make this look like a really long lopsided triangle. So if that's 80 meters and this is a pretty large angle, 84, and this is a pretty small angle, 6, it looks like this side would be a lot longer than this side. Makes sense, right? So you'd say something to that effect. So since 6 degrees is a small angle of depression, the opposite side of the 84-degree angle is going to be large, right, compared to the 80-meter length height. Again, sorry about my terrible handwriting. I'm trying to not bore you by writing. Okay, cool. So here, to what extent does the height of the person affect the calculated value? You know, I'm kind of like happy that they said that, because maybe they wouldn't have said that in the other, components. So let's take it, like maybe they wouldn't have said that and you would have had to have inferred it. So let's do this. And then let's add this little person's 1.6 meter height to it. So here's 1.6 meters. So now our triangle is now 81.6 meters. And so that's going to throw our triangle off a little bit. We're going to have a little bit, I think that it's going to be changed. This is still 6 degrees and 84 degrees. But now our triangle looks like this, where this is 81.6. This we don't know. This still should be 84. And so you can still say, or what is this, D? You could still say tangent of 84 equals opposite over adjacent. And so your new D value is going to be tangent of 84 times 81.6, 776.372, blah, 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 blah. So 776, round that down, right? So we went from, what's 761? So without the height of the person, it was 761. And then with the height of the person, I guess this was called T, it was 776. So these are meters. So this is the difference of 6. So okay, so like 15. So the difference between here and here is a 15-meter difference. So that means we're adding to this one, we're adding 15 meters to it. I guess it would be like this if we drew it out. This would be the other triangle with the person's height, and the difference would be 15 meters. Okay. To what extent does it affect that? Well, it has a 15-meter increase. So you'd say there's a 15-meter increase when you take T, the person's tallness, height, into account. That's good, but let's see what percentage we increased. So if you said 15 is what piece of 761? I got 0.0197, which is around 0.02, which is around 2%. So this is 2% of this. So if we take the person's height into account, you get something that's 2% bigger. This is 2% bigger. Because we're 2% off, this really isn't that statistically significant. We'd say that if it's over 10%, that's maybe you want to write that down, hint, hint, hint. If it's over 10%, we'd say it's significant. The change is significant. This is under 10%, so it's not significant, right? Think about like, if you've walked, this is 75, this is 3/4 of a kilometer. So if you've walked 3/4 of a kilometer, I don't know, it's like from here to the Zethus Bad, and you had to walk 15 more meters. That's like walking a couple of classrooms. If you've already walked most of a kilometer, does 15 meters more matter to you? No. Right? So it's not significant. Right? So I think like that the height of the person is not necessarily significant. You justify your answer by showing this. Sometimes you'll hear this called percent error in science. There's an equation for it. You're welcome to look it up, but I don't think it's worth looking up because it makes sense. You look at this little increase and how much the increase is of the original. You look what percentage of the original it is. And then if it's over 10%, generally we say it's significant. If it's under, we say it's less significant. Cool? I hope that helps. Practice some of your application problems from your packet, and I think that'll get you ready for the Criterion D.